This is Perez.
Okay, so we're first going to go over a couple questions with function transformations. Now, in your Unit 1 post-test, you're going to get about 4 questions on each tile. So you'll get 4 questions pertaining to function transformations. So before I get started on those practice questions, I want to make sure all of you know that over here on this Resources tab in your tutorial, you have these guided notes. So this is just kind of a condensed version of everything in your tutorial. A lot of times it helps students take notes. It condenses the amount you're writing and has essential information for mastery tests. Those of you that are okay with taking notes and have your own, way of doing it, you don't need to use these. They're not for points. They're just for extra help. But they are really great. You just fill in the blanks, and it has a lot of useful information. So I just wanted to make sure you guys knew that that was there. The other thing I want to show you is in this. I would suggest every tutorial go in this resources tab and just check it out what's in here. Some of it you might find it interesting or useful. Is this so this one right here, the summary of functions transformations. This is going to be really useful in your post-test. It pretty much just summarizes the different kinds of transformations, and you'll need this for all 4 questions on your mastery, or sorry, all 4 questions on your Unit 1 post-test for this section. So really briefly, you'll need to know what a vertical translation looks like and a horizontal translation looks like within a equation, whether it is a parabola, uh, um, a linear function or a exponential function. And we'll go over a little bit more in depth as we do the questions. But if you don't have this summary or something similar to it in your notes, I suggest you go in your tutorial, download this PDF, and save it somewhere. Um, One thing I will go over in detail is this vertical stretch and compression, because the questions do go over this and what they look like in a graph. So definitely have this available to you for your test. Okay. Okay, and I will also go over some important pages that you should have detailed notes on. Page 10, you will have questions about this. So a reflection flips the function over a line, usually the x-axis or y-axis. The function negative f of x is a reflection over the x-axis. So we can see here this function is reflected directly over the x-axis. The function f of negative x is a reflection over the y-axis. So I know I'm talking pretty fast and I'm going pretty fast, but again, this is just a brief review of what you will need to know. If you have any specific questions or you're not following too closely, I suggest making a tutoring appointment and we can go over it in more detail. But page 10 is pretty important for your post-test, and being able to identify what kind of reflection this is just based on the graph. So you'd be given something potentially that looks like this, and you'd be able to say, okay, this is a reflection through the y-axis. So you would know that this negative would be inside the parentheses. Versus if you got something like this on top, you could say, oh, this is a reflection over the x-axis. So this negative is on the outside. Again, if you want to go into more detail, just let a teacher know. Okay, so page 10 is pretty important. You do have a question on that. Page 11, all these little clicks through here, these little orange clicks, or I guess there's only 2. Most of the questions have to do, not most, a few of the questions have to do with this dilation, whether it's a vertical stretch or compress or horizontal stretch or compress. Mrs. Kajanis actually put together a really nice PDF for you guys. So let me get that really quick, and I'm going to send it out in an email right now. Oh, no, I already have it here. So let me just, I have it kind of ready. So it'll just come to you in an email called Parent Functions. Okay. So Mrs. Kajanis put this together. These are the parent functions. You guys should all know what these parent functions are. So this is what a linear parent function looks like, quadratic function, cubic function. You won't use these three down here, so you don't have to worry about them, but all the rest of them you will use. For transformations, these are pretty important because what a parent function is a function without those movements vertically, horizontally, a dilation. They're without those transformations. So if you know what a parent function looks like, you'll be able to easily identify those transformations. So thank you, Mrs. Kajanis, for putting this together. And if you scroll down on it in your PDF, it actually, this is what it looks like on the graph, which is really important on your test. A lot of the questions are actually graphs, and then you have to come up with the equation. So being able to visually see what those are is great. And then she also broke them down into an equation. Horizontal shift is inside these parentheses within a given equation. Vertical shift, you add or subtract a constant on the outside of the parentheses. Reflection is the negatives that we just talked about on page 10. And then these get a little confusing, so we'll go over these as we do examples. But pretty much, if you had, let me see what we have down here. Oh, there's more diagrams. Thank you, Mrs. Kajanis. Vertical and horizontal stretch. Let's take a look at those real quick. Vertical compression / stretch. You do have about 2 questions on just these 2 topics. So being able to identify what a vertical compression is versus a stretch. And pretty much, let's see. What I'd like to show you, and I'm going to refer back to this quite a few times, is this equation. So if you want to write it down, or if you already have it, great. But I'm going to refer back to this a couple times as we do transformations. Now in your tutorial, they use different letters in different places. Unfortunately, Mrs. Kajanis and I were discussing there's probably different creators to each slide or each tutorial, so that's why they use different letters, but please don't be confused by that. They're just, each variable is representing a different kind of transformation or shift. So here, I just want to briefly go over this part right here, this vertical compression or stretch. Pretty much what I want you to take out of this quickly, how do I, come on, annotate, there we go. The easiest sense that we came up with is that if your constant that's being multiplied, so for instance, y equals 4 times x squared, this is going to make it skinnier. So if your constant, I'm just going to label it a, because in my equation I have it as a. If a is greater than 1, meaning a whole number like 2, 3, 4, this is going to make it the graph skinnier. And this is just an easiest terms that we could come up with, because this concept does get kind of confusing. So a is greater than 1. This is going to make your graph skinnier. And you can see the green is a little bit skinnier than the parent graph, which is blue. All right, if a is a fraction, which is less than 1, is greater than 0, this is going to make it a little, we'll just call it fat. Or wide. We could fat or wide. Wider. I don't want to use wide because sometimes it's the other way around. It's the graph, let's say that. Okay. And you can kind of see here that the variable that's being multiplied, the 1/4 right here, that transformation has made the graph fatter. So that's kind of the easiest way we can explain it pretty quickly, without going over a ton of examples. So hopefully that's slightly helpful, and I'm sure this PDF is going to be really useful on your test too. Okay. So that's kind of what I wanted to go over before we even started our examples. Mrs. Kajanis, could you let me know if there's anything that I should answer, any questions arising, or if I'm going too fast or anything?
So far, nobody has asked any questions, but if you do, please let us know. Nobody has asked anything, so I guess we'll just move on to the practice problems and see how this applies.
Okay, sounds good. All right. So, okay. So here's my first practice problem. Why these are highlighted, I'm not quite entirely sure, but this is how they came up when I copied them. Okay. So which of the following equals g of x? So let's take a look at this. So right away when I look at this, I can actually let me pair it with my my PDF that was given to me. So we can just kind of check this out here. Okay, right away I can see that this x to the third power is one of my parent functions right here. Oh, where'd it go? There we go, cubic right here. One of my parent functions, okay? And so when I look over here, it has the same general shape as my parent function. It's just been shifted, right? So you can kind of use this sheet to see which kind of shift has happened. And that's where this equation that I've drawn here comes in. But I kind of like this instead. So if we look here, this graph has shifted where? It's shifted to the right 1, 2, 3. It's shifted to the right 3. So if I look at this chart, I can see, okay, it's a horizontal shift, right? Shifted to the right. And now I can break it down into left and right. So if I'm shifting right h units, this is what my equation should look like, f of x minus h. So let's kind of apply that. So f of x minus h, and then you can just count how many you shifted. 1, 2, 3. So if I shifted 3 units, then I would just plug in 3 for h. So this would be f of x minus 3. Now this is good for any one of these functions. Now all of them are different, right, in the way they look. This one has a square root. This one has a natural log. But what this little table does is it lets you apply it to any one of them, right? So this is my parent function here, x to the third power. So this would be x minus 3 to the third power. So my answer would be here. Okay. One thing I think might arise if you're not familiar with it is sometimes I like to think of it as the opposite. If I'm going to the right, it's going to be a negative in there. It'd be x minus 3. If this was shifted to the left, it would be a plus. This would be x plus 3. Again, that chart that Ms. Kajanis made really is pretty useful. I'm going to stop there with this one. Is there any questions on this problem, or Ms. Kajanis, would you like to add anything, maybe any tips or something maybe I explained funky that you want to clarify?
Yeah, and if you do have questions, don't be afraid to ask. You can send me a chat that nobody else can see if you're kind of shy about it, but I do encourage you to share your questions with everybody because chances are if you are kind of confused, maybe everybody is too. Um, so if you do have questions, let me know. If you think we're going too fast, let us know. If not, I guess we'll move on to the next practice problem.
Okie dokie. All right, so we'll go a little bit faster. So here's our next one. What happened? There it is. Okay. Okay. Which of the following expressions is equal to g of x? Okay, so I can go back over here. Thankfully, they've given you a lot of these parent functions to begin with, and then you just, say what transformation happened. So again, this is a parent function of a logarithmic function. G of x or sorry, from f of x, how did we get g of x? Well, I'm going to zoom in just a little bit so you could see. It's the same function, right? Um, it just was shifted or translated over. So it passes through the x-axis at 0, 1 with f of x, and on g of x it passes through 0, -1. So what kind of shift was that? Well, it's a horizontal shift by 1, 2. So same thing, I can go to my chart here and decide, okay, it's a horizontal shift left. So oh, I can't highlight here, but this is what it's going to look like, f of x plus h, right? So f of x plus h, well, I already established that it moved over 2, right? 1, 2. So this is f of x plus 2. And then when I put it into the actual, whatever the function is, that's going to be ln of x plus 2. Okay. I really like this chart because you can apply this to any one of these functions, whether it's logarithmic, exponential, and it shows you where the change is happening. So nice job. So okay, I'm going to keep moving on unless we have questions. I'm going to do one more transformation, just real quick with the stretch and compress because we didn't really go over that, and then I'll just go quickly into the inverse functions. What time are we at? Yeah, we started like 20 minutes late. So if you guys are able to stay an extra 20 minutes, we're gonna just continue on for our hour. If you can't, if you have other things to do, that's fine too. But we're gonna probably go maybe an extra 20 minutes if we can, since we started 20 minutes late. Okay. All right. Okay, so let me get rid of this. I'll get rid of this. So this is what I really wanted to kind of go over with you guys was this vertical stretch and compress, especially because it's kind of a topic of um, students have a lot of trouble with it sometimes. So let's take a look at this. So graph A represents the function f of x equals the cubed root of x. So that's graph A. So that's the blue one. Let me get a blue. So here's my original function, or my parent function. So graph B and C are transformations of graph A. The function represented by graph B is g of x equals blank. So they want to know, okay, what happened to graph B from A? So B is the green one. So as you can see, it looks, it's the same function, right? It just got, oh, this is not a vertical stretch or compress. Darn it. This is just a transformation again. All right, well, this one has moved, right, to the right 1. So this is going to be, again, a horizontal shift to the right. So it's going to look like this one. So this is going to be f of x minus h, which is f of x minus, so it moved over 1, so it'd be a 1. Now when I plug it into this particular equation, it's going to look like this. F of x equals cubed root of x minus 1. Like that. Okay? Darn, that wasn't a vertical horizontal shift. All right, so let's take a look at C. C is my red one. Same thing. It's the same function or same graph like shape. It's just moved down 1, so it moved down 1. And what I'm doing, I'm just looking at the where it's crossing the x-axis, and that's how I'm telling how it's shifting. Okay, so this crosses at 0, 0. Now it's moved down. It's crossed at 0, 1, -1. So if I look at my little chart, my vertical shift down, I notice it's going down, so my function should look like this. So it should be, let's see, let me make this a little bit smaller. So my vertical shift down should look like f of x. And notice what I'm doing is I rewrite a lot. I rewrite, the information I have from my notes, and then I just fill in what I know from the question. So now this is f of x minus, okay, how much did I go down by? 1. And then I plug it into the actual function it gives me. So this is, I'm just going to go up here and rewrite it. So this is f of x. Notice on my chart, the k is on the outside of the parenthesis. So that's exactly what I'm going to do in my function. So this is f of x equals 3 cubed root. So this is a root, not a parenthesis, but still. So it's not going to go inside like it is here, because that's how it's shown for the horizontal shift. The change, the h, is inside. This is going to go on the outside. Okay. All right. Okay. That's it for transformations. Okay, what was this one? Nope, same thing. Okay. All right. Maybe we'll circle back to transformations, and I can find a vertical stretch compress one to go over, because you do have one or two of these kind in your test. You can refer back to page 10 and 11 though, just to review. But let me get into inverse functions. So we're going to shift over now to inverse functions. So let me get that tutorial open. Let me get rid of this. And if you want to go over one of those vertical stretch compress questions, personally with a teacher, just let us know, and we'll set up something. All right, so we're in inverse functions. I'm going to go over two kinds of problems, practice problems, but again, check your resources folder for guided notes, logarithmic properties, your glossary. So you have this resources tab. Please utilize it. Some important pages that you should know for this section are page 20. Okay, so page 20 pretty much breaks down what you need to do to find the inverse. So it says, let's use the same idea and process we used for the temperature conversion formula to see how we can find the inverses of functions. So when you're asked to find the inverse of functions, these are the steps to take. I would have them down. Replace f of x with y, then reverse the roles of x and y, solve for y using inverse functions. So this is something you need to get really good at, using inverse functions, or what I usually call opposite operations, to solve for a variable. So yeah, I have these steps down. So page 20, and then having these examples in your notes is going to be really useful, because your mastery test, your Unit 1 post-test questions are almost identical to these examples on page 21 and 22. So having these down, if you don't know how you got from this step to this step to this, like what they're doing here by solving for a variable, contact a teacher so we can help you out with those steps. I will go through an example in the example problems, but page 21 and page 22 are pretty useful. Let's see, definitely page 21. I would have definitely this one in your notes, because there's a similar one in there. Page 22. So just expect a question on something similar to that. The other thing is on page 23, rational function inverses. You do have to pay attention to the domain. Okay, so whatever's in the denominator, right, restricts your domain. So just kind of note that. Let's see, you can maybe highlight this. All right, that's important to remember for inverse functions. I would 100% have this problem in your notes, and the steps to solve it, because you do have a question very similar to this. So have all this down in your notes. If you don't know how they got from one step to the other for solving for an equation, contact a teacher so we can help you out with those steps with solving for a variable. And lastly, what I would focus on, and again, if I'm going too fast and you weren't able to write down those page numbers to focus on, just chat it, and Ms. Kajanis will let you know. Page 28 and 29, please have in your notes, because you do have a question on your test about this. So this process right here, you have one almost identical to this one, and this tidbit right here. Since the range of the initial function was y is greater than 0, the domain of the inverse function needs to be restricted to x is greater than 0. Therefore, we can write the inverse function in an equation as f of -1 of x equals x squared minus 2x. So let me explain this a little bit. So pretty much what it's saying is if you're given this radical function x plus 2, f of x equals x plus 2, and you know the domain of this function is x is greater than -2, right? One of the reasons because you can't have a negative number in a radical. Okay, and I'm going kind of fast because this is just kind of stuff you should know, but that's nothing that I can't slow down enough and explain at a later time. But you can't have a negative in a radical, so that's why the domain is restricted. So whatever's in a radical, you set it equal to 0, and the range is x is greater than -2. So when you find the inverse of this function, right? When you go through that process of finding the inverse of this function, the domain and range flip. So that's what this chart is showing you, and this is important in your test to understand. Is that the domain and range flip for inverses? Okay. Here it says to make sure you can graph this, and I think I have it open here. Oh, I don't. Okay, but I can put it in real quick. Use GeoGebra Desmos as often as you can. I think, or is it x plus 2 or x minus 2? I think it's x plus 2. Okay, so when I graph this, you can see all the domain is greater than -2, right? You don't see this function anywhere else besides -2 and further on. Okay, and then the range, right? The range is all the y values. What y values are included? Well, y values are 0 and up forever. Okay, so that's the domain and range of this function. So if you can find the domain and range of the initial function, all you got to do is flip the domain and range for the inverse function. So that's pretty much what that part of the tutorial is saying. And you do need that information for your test. So questions on that, just let us know, and we'll get to it. I'm just trying to go at a certain pace, so and I'm trying to go a little fast so we can get through everything. But I just want to emphasize this is on your test, so if you need help with it, please ask. Okay. And then that's it from your tutorial. So please focus on those pages, and it should really benefit you. Okay. So let's get into the practice problems. Okay. So inverse function, first question. Place image. Okay, and I'm just going to write, I'm really hoping you guys can, know those pages 20 through 22, knowing the steps. These are the pages I want you to focus on, 23 through 24. This is rational expressions. You need to know how to solve for those or find the inverses. And page 28 through 29, these are radical. So if you need to focus on those pages, and if you have trouble with any one of those, please contact a teacher. Okay, so this question, find the inverse of the following function. Okay, so maybe I'll have this open over here. Oops. Oops. Okay. Okay, here's my steps. Got them. So this is kind of why you need them, because we're going through here. So find the inverse of the following function. Step 1 is change f of x to y. So this is going to be y equals the fifth root of x over 5. Okay, did that. Check. Oh, I can't mark over here. That's okay. Step 2, reverse the roles of the variables by swapping their positions. So all that means is that I am going to change x for y and y for x, but everything else stays the same. Just one second. I think we have a question. Okay. So swapping x for y, y for x, everything else stays the same. Okay, check. Step 3, solve for y to produce the inverse function. So this is where some students, like, if they aren't don't have a strong background with using inverse functions or the opposite operations, this is where you run into trouble. These skills are an Algebra 1 skill, but we're dealing with a little bit more complex equations. So just if you're a little rusty, this is where you should practice. Okay, so wait, where'd my y go? Oh, my y's gone. Okay, there it is. Okay. So I need to solve for my y using opposite operations. So let's get rid of this 5 first. So what I'm going to do is I'm going to use a different color. I'm going to multiply 5 on both sides to get rid of it on this side. And I'll back it up to level 1. Solving for a variable, we're trying to isolate it, get it all by itself on one side. So so 5 divided by 5 is 1. So I'm left with 5x on this side equals the 5th root of y. Okay, so again, opposite operations. If to get rid of a root, you take the exponent of it. So I'm going to now multiply or take this to the 5th power. What I do on one side, I do to the other. Okay, and when that happens, it kind of this kind of cross cancels each other. These the 5th root and the exponent. So I'm left with just a y now. Yay! I'm left with a y. Now this is where maybe math creators try to trick you. All right, so this is you gotta use your exponent rules. This is 5 to the 5th power and x to the 5th power, so you have to evaluate that. Okay, so don't get tripped up and say, oh, this is the answer. No, because there's parentheses around here, so this 5th exponent, or to the 5th power, gets kind of distributed to the x. It gets distributed to the 5. Okay, parentheses play a big part in the difference in having them or not. So just pay attention to that. So when we evaluate this, let's get on our calculators. 5 to the 5th power, you should get 3, 1, 2, 5. X to the 5th power is still x to the 5th power. I think our last step is just replace y with f of negative 1 of x. Okay. So I don't think finding inverses is where a lot of students get tripped up if you already have a pretty good background of solving for a variable. It's just taking your time and checking for mistakes and stuff. So so this answer would be this one. There we go. Okay, any questions on that one? Awesome. Okay, I'm going to delete it. If you have those steps, it makes things pretty easy. All right, last one from me, inverse functions number 2. All right, I'm going to put this one back up there. I'm going to zoom in. Type the correct answer in each box. Find the inverse of the given function. Okay, so this is a good one to go over just because it has this domain thing. So remember, you will in your test have this part where it wants to know, okay, how is your domain restricted? So just have to pay attention to those pages, which I think, did I write them here? I must have deleted them. Oh, they're way over there. Okay, so let's go through our steps again. Step 1, we begin by replacing f of x as y. So let's do that. So we have y equals, oh, why is it going so slow? 5x plus 1 over negative x plus 7. Okay, and the domain is restricted here as x does not equal 7, because if it did, then this would be 0, and we can't divide by 0, otherwise the world goes into chaos. Okay, So step 2, reverse the roles of the variables. So now we got x equals 5y plus 1 over negative y plus 7. Okay, step 3, solve for y to produce the inverse function. So the first step in anything you get like this, obviously is to get rid of this fraction. So we're going to just multiply this whole denominator by negative y plus 7. And I'm going to do that on both sides. I'm going to multiply by negative y plus 7. Okay, when I do that, I get x times negative y plus 7 equals, these cross out, boom, boom. Okay, and I'm getting a 5y plus 1. Okay, so from here, we can't. Ooh, let's not look at here for now. Let's distribute this x first. So let's do only because if you notice there's a y on both sides, and we don't want that. We want all the y's on one spot. So let's distribute this x. So x times negative y is negative xy. X times 7 is 7x. And this is a pretty similar process to the problem in your test. This procedure that I'm doing. So if this part is what you're struggling on, copy it down because it's almost identical. Okay, equals 5y plus 1. All right, so now let's get all of our y's together, let's get all of our y's and x's together. Okay, so I'm actually going to move my y over here. Yeah, so I can pull out a y. Okay, I need a little bit more room, so I'm going to delete some of this stuff. Mrs. Kajanis, is it okay if I delete this top part? Okay. Oops. Okay, so we got negative xy minus 5y. And I still got a plus 7x over here, but I'm going to move that pretty soon. I'm going to subtract 7x minus 7x. I'm going a little bit faster, but I can slow down too. So negative xy minus 5y equals negative 7x plus 1. Okay, all my y's are in the same spot. So I wish I had your voices on because I would say, what do you do now? Let's find the GFC, greatest common factor. So that would be y. So I'm going to pull out a y from each one of these terms. So when I pull out a y, that goes on the outside. And I'm left with a negative x minus 5 equals negative 7x plus 1. Okay, great. Now I'm here. This is y times this expression. So the opposite operation of multiplication is division. So I'm going to divide by my negative x minus 5. That's a really bad 5. Negative x minus 5. Okay, that is all done. So what I'm left with is y equals negative 7x plus 1 over negative x minus 5. Okay, now we have two negatives here. We got to fix that. And we have a domain. Okay, so actually let's do our last step. Replace y with f of negative 1 of x. F of negative 1 of x equals 7x plus 1 over negative x minus 5. Okay. So I think Mrs. Kajanis worked this out earlier. Miss Kajanis, is this right? Only 'cause, and you can make very small arithmetic mistakes. So I haven't worked this out yet. So I just want to make sure all this is correct. Did you get the
Uh,
same thing?
okay, let me see. I did.
Okay.
Um, all of these practice problems regarding the inverses, for some reason, like they're not happy with that. They want you to go an extra step. So the extra step that they want you to go is multiply the top and the bottom numerator and the denominator by -1.
Okay.
So,
All the
um,
signs change.
mhm. For,
Okay.
so your denominator is correct. Wait, hold on. Yeah, you have it correct actually.
Okay.
Yeah, seems like you
Okay.
already did that.
Okay.
Yeah.
All right.
So
Cool.
the part that's correct is next to the big X, the big red X.
Mhm.
That's the answer that they're looking for.
Okay. Cool.
Okay, any questions about this one?
Well, lastly, what we're gonna do is this domain part. So, how is my domain restricted? Right? What can x not equal? Well, if we plug it, negative x minus 5. Pretty much your denominator cannot equal 0. Like I said, if you divide by 0, then the world goes into chaos. Can't have that. So let's set our denominator, whatever it is right here, equal to 0. And that tells us, and solve for that variable. Come on. My pen's not working. Oh, I must not be able to type down here. But anyway, you're going to solve for your variable to figure out what the domain restrictions are, which would be -5. Does anybody want me to solve for the denominator to show how I got -5? Or is everybody good with the -5? Okay. Alrighty. So that's it from me. Mrs. Kajanis is going to take over for a little bit and do the next couple examples. Sorry that mine took so long. I do want you to cover those pages though. These, just make sure you're good. And then from transformations, we didn't really go over the vertical stretch or compression. There is a couple questions on there. Mostly you just need to be able to identify, which one it is, if from a parent function, if it's fatter or, really skinny. So if you want to go over that at a later time, if that's something you're struggling with, please just contact us. But yeah, that's it for me. So give us a couple of seconds to switch over. Okay.